What can we do with this file? First, probably the most basic, we can watch the properties, right? And the properties, it's interesting that malware has a digital signature. And this is like Microsoft Windows. It's a real, like trusted Microsoft Windows signature. But as you can see, it's not valid. It means they just copied the digital certificate from Explorer or any other Windows system program. They embedded into this program, but the thing, the hash, the checksum of the file doesn't fit the hash in the certificate, which means this digital certificate is just a dummy certificate, and it doesn't verify the integrity and the authenticity of the program. It's added because some antivirus software, they just check the presence of the certificate. They do not care about if the certificate is valid, because in this case, you need to perform two checks. If you design antivirus or any security solution, you need to perform two checks. First, if a digital certificate is available. And second, which is also mandatory, it's not optional, is to check if it's valid, if it's not expired, if it has the same hash as the file, and in such a way you can verify that indeed the digital certificate corresponds to this particular file. In our case, it's not the case. And certificate is Microsoft, is real. This is a certificate is used to sign Windows files. Okay, another interesting things, for example, if you go to details, we can find the PE file description. It's usually included when we are going to study static analysis approach and tools. I will show you that at the end of the file, there is a version info structure added to PE file, and this version info structure contains information about the producer, like manufacturer, vendor, software vendor, original name of the file, name of the application, and other stuff, a product version. And here, it's quite interesting that the file description is in Russian. And it tells that this is the Explorer. This is a Russian version, Russian name of the Explorer. And this can give us some thoughts on attribution. So as I mentioned, we have a war, Ukraine has a war with Russia, and we've seen like many attacks since 2014, and this seems to be one more nation state attack that targets our ministries. So that's an interesting thing. Then, of course, IDA, probably the most mature disassembler currently available. There is also a Hydra that is used by NSA, but again, Hydra is delivered. You can download only the compiler in Hydra, and if you want to have like a full package, the compiler plus debugger, then you need to buy it. So in this case, IDA freeware is much more convenient, because even though it has no decompiler that decompiles assembler code into C or C++ code, still you can debug. And debugging is probably the most useful feature, because take into account the modern variants of malware, the attackers, they apply obfuscation on code and data, and it's not possible to decompile obfuscated, which looks broken in assembler code into C or C++. Because the structure is broken, and sometimes they use runtime code decryption, which means if malware needs to execute some specific function, it just decrypt it on the fly or just decode. Sometimes like very basic ciphers, I used symmetric cipher, sometimes XOR operation, RC4, or even base64 encoding is also sometimes utilized. And then they decode, execute this function, and then wipe the code of the function from the memory. So it's really hard to analyze, and it's really hard for tools to decompile to parse the structure and represent it for malware analysts, making life of malware analysts harder. So well, what we can see, actually, we have like a lot of data. And this is a MS Core EE. This means this is a .NET application. It uses this library, which is a .NET library. And this is an entry point where all program the program starts. But the thing is, if it's a .NET application, so we can try not debugging, for example, but decompiling. This is another way how you can approach analysis of malware. Not only disassembly and debugging, but also in some cases it's useful to decompile. I use dnspy, and for example, once I open, yeah, indeed, it's .NET Core. So again, this is information that we saw in details of the program. As I mentioned, it's stored in version for structure in the footer of the PE file. And this is a MS Core lib that is used by this application. And then you can just go through. So there is a PE header, which we're going to study during static analysis module. Then we have probably that's the most interesting part. Or just you can go through some of the function here. And yeah, when you start like watching the program, the main goal of malware analyst is to find the sense of what's going on inside of the program. So what is the payload? What is the features of this malware? What this particular malware can do to the target? Which particular data can be stolen? What the damage is done, and what servers this particular malware is communicating with. And when you try to give it a sense, sometimes it's not possible, because what you can see now is a like very vivid example of obfuscation. Obfuscation is when the attacker try to hide the code and try to, you can see, using this like strange math operations. And a lot of cases, I mean, there are a lot of branches. This is called code flow obfuscation, when the instructions are not executed just one by one, but there is a switch case construction, and it executes not in the direct order, but the calculation of the previous case is used to jump to another case. And in such way, they decode some data, defuscate the code, defuscate data, and then prepare to start the payload. Well, in other words, we cannot get any information from this. So just, I'm going to close it and probably not return. So another way how we can try to figure out what this particular application is doing, dynamic analysis. Dynamic analysis, when we just execute this application and see in monitors, so we'll have a separate module on dynamic analysis. So I'm going to use, well, Wireshark. I think it's well known, very good network sniffer. So you need to select an adapter. And here you can apply filter for specific IP address, protocol, whatever. So for example, yeah, this is just ongoing activity running in my operating system. Then I think it's also useful to use process monitor, which was originally created by sysinternals, and Mark Rusinovich is the founder and CEO of sysinternals. Now he is the CTO of Azure. Very cool guy, and I would say influencer in Windows security community. So here we can set up again filter. For example, in this case, we're going to filter only process name, and the process name will be stage 2, I believe. Yeah, that's correct. So okay, we have another one running. Makes sense. Just need to check filter. Stage 1, no, we need to monitor stage 2. So this red ones is excluding the information from the list, from the log, events log, and this is what we are going to include, the green one. Okay, and these are 4 monitors that we are going to use: registry monitor, file monitor, network monitor. Just the basic TCP connection events will be shown, and system events that represents mostly process threads, process and threads activity. So we are all set. Then I just started. It is essential to run it inside of the virtual machine, not on your laptop. So let's go to process monitor to see. And you can enable, disable different monitors to see the activity that you need. So you can see that it starts some PowerShell, it prepares the PowerShell. And what I want to see is, yeah, can you see this? This is a network connection. And now I can go to my Wireshark and specify the filter for the specific address. And it's going to be 162, 159, 130. So this is a template. 233. So that's it. Then we are curious, like to which server this malware is communicating. We open client hello request. This is a TLS handshake, and we can find the interesting the server name, cdn discord application.com. And this means, yeah, that's proves the suggested payload that this is a Trojan downloader that connects to Discord. Discord, it's a social network, to download another malware. So Microsoft tells that another malware is going to be like a file wiper, the application that wipes the data from the files that has specific extension like Excel, document, source codes, databases. One more question in the chat: would not malware try to detect, for example, process monitor or EVM? Yeah, that's one of the features that malware can have, but not in this case. My personal impression about this attack on Ukrainian government institution, even though it was just discussed everywhere, I read articles in Reuters, in BBC, in New York Times, like everywhere about everyone is talking about this attack. Because yeah, we have this political things like counteraction, NATO and Russia, and Ukraine is also in the center of this conflict. And my personal opinion that this attack is very simple. I mean, the code is very simple. It's not well designed, and it's not even close to NotPetya. So that's my personal feeling. But of course, the damage they caused not good. But it's easy to repair, because if it's not about file wiper, if we talk about only about MBR replacement, rewriting, so MBR, it's easy to restore once you have a DVD like a bootable disk. So you can start with a Windows bootable disk and start troubleshooting and fix the MBR. That's not a problem. However, the part that is about replacing, wiping the content of the file, it's more sensitive and more tricky, but not so damageable that as NotPetya. Well, that's how we can analyze and see, and indeed it connects, but seems to be it doesn't. The size of the packet tells us that it doesn't download any big files. And if it downloads, so we'll be we'll be able to see that a new process is started, but that's not the case. The process is exited. So this part is not very interesting. I'm going to close the monitors. Let's, we have 15 minutes left. Let's take a look at another part, which I believe more interesting for us. So again, we can go to properties, but here we don't have any digital signatures. And this version infrastructure was not filled by the attackers, so they do not actually invest. Yeah, sometimes when you analyze malware, sometimes Windows automatically turns Windows Defender and starts detecting malware that you analyze. That's why I recommend using this Windows XP image, where you don't have Windows Defender, and Windows Defender will not interrupt your analysis. Yeah, that's the file that we are going to run and analyze. So supposedly the Windows Defender just analyzes all the files on access. So when you open a file, they check, they enable Windows Defender if it was disabled, and check. And that's not good, because we need to, yeah, it's actually disabled. It's disabled. You need to disable it if you want to work with it, with malware. Well, I still have it in archive. So another secret that all the files, all malware that you can download from sandboxes, so VirusTotal, these files are password protected, and the password is infected. This is like a tradition which started like many years ago. I believe like 20 years ago, it was the same password used to protect files against detection by antiviruses and deleting these files. Okay, this is going to be stage 1. So let's try one more time. Yeah, it is essential to know. Actually, you will figure out after you already analyzed, but I'm going to save our time. It is essential to run IDA as administrator if the malware requires elevated privileges. In our case, malware is going to overwrite MBR, and to do that, it gets direct access to physical drive, and this operation requires privilege escalation. So, which means the privilege escalation techniques are not included into this binary, and this means that the attacker have to think about privilege escalation and get this command shell with administrative privileges, and then run this application from the command line that has administrative privileges. In our case, we need to care about this and just run our debugger. And one more time. Okay, seems to be all working fine. So here we are. So this is the entry point. You can see the start. You can find it in export. By the way, there are two callbacks. This is a multi-thread application, and these callbacks are used probably to access from another tool to check the status. But we need only this part. So then we can just immediately start with debugger. We set breakpoint here. You don't need to get into details. I'm just show how it looks. Just you have like a general impression about reverse engineering and what particular you need to know to actually to do the same. So then, like in software development, you need to set up breakpoints in order to stop, interrupt the program, and see some functions, see some details. And to do that, you can review the code here, like manually. By the way, there are two modes. Like there is a mode text view. This is a classic mode. But if the code is well structured and this particular program is not protected, it's not obfuscated, and that's why I say I state that this is quite basic. This is how it works, and so in one of these functions we can find something interesting. But to save our time, I would recommend just to go to set a breakpoint on calling the most important functions that, for example, work with the files. To do that, actually, we can take a look at the modules here and select, for example, kernel 32DLL and select one of these functions that we want to, where we want to set a breakpoint. Another way is if we open imports. Then we will see that the list of imported files, and it's real. This import table is not fake, like it's usually done by malware authors. That's a real one. And we have here create file, and I can set breakpoints here. Then what's interesting here is, yeah, this is searching for files, but get command line. So there is a parser of command line, so we can send some parameters to this malware. And we can actually watch it here. Write file. Writing data to MBR can be done using write file function. That's why we are interested. And then we resume. By the way, it's a nice practice if you use dynamic analysis at the same time with debugging, because you can miss some parts you cannot set breakpoints in all the parts of the application. That's why the only thing you need to change it to stage 1. And I'm going to select file monitor. Yeah, that's it. And I resume my application. First, it stops at get command line. So if I continue going, so there are like, as every debugger, it has several options: step into, step over, run until return, run to cursor. So if I continue following, yes, downloading debugging symbols, I will get to the kernel-based library. This is specific of this application. And here, by the way, I can see the argument passed to this function. And you can see this is the path of the application. So, and it has no any arguments. Okay, so we are done here. By the way, we can also set breakpoints here, just for any case. But let's run it to find another. There is a loop. We don't need breakpoint here. Create file. That's interesting. And there is a pass data to the function, and this pass data is a pass to physical drive 0, and this is a return address. So when you call the function, the upper quote need to push into the stack the return address. The address that will be used by return operation from the function. That's the one, by the way, that's the function call. So the return address is going to be next instruction after the call. And that's interesting. That's actually the file that is going to be opened. A create file is used not only to create file, but also to get access to existing file. In this case, the program tries to open the handle to physical drive, just get access to the physical drive. And it requires, as I said, administrative privileges. If you have like run debugger not under admin privileges, so it will return like FFFFF, like failure. The function this will return failure, and as I said, there is no exception handler. So if it fails, you won't know about that. Then this is a quite strange way of passing the arguments into the stack, into the function. And here they just directly assign these values to the stack. ESP, it's a stack pointer. So all these values will be written to, actually we can see it. This value, this. So all these values are passed in the stack. And this is the return address. So that's first interesting thing. Actually, this is the place where it gets access to a physical drive in order to write MBR. So yeah, just going back, set breakpoint here. Yeah, and in registry EAX, if it succeeds the function, it returns the handle. If it doesn't succeed, it returns some invalid value, for example, FFFFF or all zeros. Then we have another call, write file. Also quite, this arguments pass in a quite strange way. So I just resume it to write file. And this is the size of written block, it's 512. And this is a data actually. So if we go here, yeah, I think there is a much better way to view it if you open hexdump. And here I want to see the memory by the address stored in EX register. And voila, that's the ransom note is going to be written in MBR. Your hard drive has been corrupted. In case you want to resolve all your hard drives, of your organization, you should pay 10,000 K via Bitcoin wallet and send message via Tox ID. So that's the message going to be stored instead of MBR. And yeah, that's our, so actually, I just need to check. Yeah, this is how it gets access, all access granted, success. And I resume it. And so here, the application successfully wrote 512 bytes into the MBR, into the partition, into physical drive 0. And now the most interesting part. Let's reboot it and see. So, well, the MBR is corrupted and the operating system cannot be started. So that's a like general idea of reverse engineering and how it can be applied to malware analysis. And this shows actually why do we need to study malware analysis and how it can be applied to investigation of the real cyber attacks.